Let's look at a sample problem. Here's the following sample problem. Hydrogen bromide is a gas at room temperature. It is soluble in water. Okay, so when we dissolve it in water, it becomes hydrobromic acid. So identify the conjugate acid-base pair. So here we're starting off with the reactants. Okay, so figure out now what the products will be. And then figure out and then label which ones are your acids, which ones are your base, which one becomes your conjugate acid, which one becomes your conjugate base. Which one of these is the acid? Or that's going to act as the acid? HBr, right? The hydrobromic, right? Hydrobromic acid. The water is what's going to act as the base. So which one's going to give up the proton? The hydrobromic, right? It's going to give up the H to the water to form the hydronium ion, right? So this is what ensues in the end. So we know that, here we've got the hydrobromic acid, right? This is the acid. The water here is going to act as a base. It's not a base, but it's going to act as a base. Now, which one of these is the conjugate acid? In our products, which one of them is the hydronium ion, right? So this is going to be the conjugate acid, which means the Br negative is the conjugate base. So if we're looking at something called the conjugate acid-base pair, we're always looking at it as the acid has a conjugate base. All right, so we take acid and think of it as this way. Acid with the conjugate, the linked with base. Right? So this is what we call the conjugate acid-base pair. So the hydrobromic acid with the bromide ion are considered the conjugate acid-base pair. These two are conjugate acid-base pairs to one another. So they are also another conjugate, right? Conjugate acid to base, conjugate base to acid, or whatever you kind of want to name it. But it's always, if you have an acid, you've got to have its complementary, which is its conjugate base. Last sample problem. Ammonia is a pungent gas at room temperature. Its main use is in the production of fertilizers and explosives. It is very soluble in water. It forms a basic solution that is used in common products such as glass cleaners. Identify the conjugate acid-base pairs in the reaction between aqueous ammonia and water. So take a moment and actually come up with their conjugate acids and the conjugate bases. Which one of these two is going to act as the acid? The water. Which means the ammonia is the one that's going to act as the base. So which one of these two is going to give up the hydrogen proton? The water is going to give up the hydrogen to the ammonia, right? To form NH4, right? The ammonium ion and the hydroxide ion. So which one is the conjugate acid? The ammonium, right? And the hydroxide is the conjugate base. So you want to look for, right? The conjugate base is easy to find if you got OH in your ending. Right? The conjugate acid is easy to find if you've got the hydronium ion. Do we have the hydronium ion? No, we have the hydroxide ion. So that's why it makes things a little bit easier. But another way to tell is which one of them gave up the proton, which one picked up the proton. So if it picked up the proton, it's the conjugate acid. If it gave up the proton, it's the conjugate base. So which ones are the conjugate acid-base pairs? Ammonium with ammonium, with the ammonia, right? The base with the acid, but it's the conjugate. And which means that the water is a conjugate acid-base pair with the OH. So notice the pairing. Acid with a conjugate base, a base with a conjugate acid. Those are the pairs.